All right. Good morning once again. Oh, that's cool. Sweet little handshake. I don't know what's happening. Hello at home, everyone. Today, our final concept on demand regarding the idea of elasticity. We've touched on it already a little bit. But quick recap, and then I want to get into the lecture portion and give you guys an opportunity to do some calculations with me. So, first off, elasticity, if you guys recall, is a mark of how responsive we are to a change in price. Yes? That is, does our behavior change or does our behavior not change? So eyes right here. Eyes right here, please. Look at this rubber bands. Rubber bands are stretchy, elastic, dynamic, right? They change with some force applied, right? So if we, as consumers, are changing our behavior when the force applied is a change in price, if our behavior changes, eyes here, and stretches or is dynamic, we would say that our demand for that product is relatively elastic. Okay? Not perfectly elastic, but relatively elastic. And we'll get into what kind of goods, products, services are elastic. For something that our behavior does not change when price changes, that is, watch here, price changes and there's force applied, but our behavior doesn't change and doesn't stretch and is not dynamic. It stays relatively set or relatively inelastic. We would say our demand is relatively inelastic for that good, service, or product. Make sense? So here's what's going to happen. You guys are on your whiteboard again. I'm going to grab a whiteboard, and we're going to go ahead and call this lecture today Elasticity of Demand. I'm going to go ahead and share the screen. Screen 2. There we go. Should see that at home. All right. Okay. We're going to call this, and again, just like you've done Friday and just like you've done on Monday, you go ahead and title it Elasticity of Demand. All right. So first off, I'd like you to go ahead and get the definition down. And then again, that is how responsive we are to a what? Change in what? Change in price. That is the definition of elasticity of demand. How responsive we are to a change in price. That is, does our behavior change or flex as price does? Okay. So how responsive is our behavior? When price changes, does our behavior change as well? All right, I'm going to erase, and let's do this for you guys. On yours, I'd like you to take, like, maybe do this on your notes, or a line across, and then cut the rest of your paper in half like this. Okay, I'm going to go ahead and erase this, but actually, I guess I don't have to. We'll call one side relatively elastic. Okay, and we'll call this other side relatively inelastic. And again, we are simply trying to figure out and note how responsive we are to a change in price. Listen, have you guys gone into a marketplace, a grocery store, what have you, and gone in and saw something that you kind of wanted, but you saw the price had gone up, and you're like, I'm not going to buy that today? Has that happened to you? Raise your hand. Yeah. Okay, that means your demand for that would be relatively elastic. Okay. Or have you seen something where you maybe have desired it or wanted it, but you kind of stayed away from it to some extent, and then you saw price drop, and that enticed you to purchase it, right? Raise your hand. So that, again, would represent relatively elastic demand. That is, price changed and you price dropped and you bought more of it than you would have otherwise. So let's go ahead and set your coordinates. Don't set D1 yet, but let's go ahead and set our price and quantity coordinates, okay?
On both sides?
You can set for both sides if you want. Sure, might as well. I think I might be running out of room, so I might be starting over here in a second. See if I just grab a new whiteboard. Okay, so I'm going to focus on this one first. Don't do this on your notes. This is going to be number 1 graph for me. I'm going to the whiteboard now, larger scale. Good enough? Okay, this will be the second one. So I'm going to erase, and then I'll do the second one here. So go ahead and get set up. We're talking relatively what? Elastic for graph 1. Price and quantity. Okay. Okay. Relatively elastic curves look a little bit flatter. Okay, and I'm going to demonstrate why. So first, here's your relatively elastic demand curve. Go ahead and set that. First off, I want you to just simply remember that a relatively elastic demand curve is more flat. Good enough? Okay, so you have that now. But now we want to look at why. That is why, how does this graph demonstrate that our behavior has changed as price has changed? So what do you guys want to do? You want to, let's do this. What are we in the market for, first of all? Somebody, let's take product. Goats. Can we, okay. Goats will work. I'm trying to pick something that's, yeah, we can do goats. We can do cheese next. Well, maybe if cheese is a need. Well, let me do this. Let me pick something. Cheese is a necessity. It kind of is for me too. I like cheese. But let's do this. Let's.
Chopsticks, soft lips are always key.
We're gonna have to save that one. Okay. Oh, soft lips are always key. All right. Let's do this. Nope. Nope. I'm just gonna simply say. Let's do this. Candy. Candy. Jeez, you weirdos. Don't mind the class people at home. This is first period. They're special. They're special sort of group. All right. Love them to death. Special sort of group. All right. Let's continue. So if we're saying candy, we're assuming candy is a good that tends to not be something that is in need but a want. We'll get to that in a minute. Here's what we want to show. Let's just say that the price of candy has starts here. So let's go ahead and set P1. Okay, and we're going to bring it across. To a quantity of 1. Or quantity 1, I should say. We're not setting numeric values right now. Not worried about that, just conceptual. And let's say the story, after you've gotten that down, let's say the story goes, the price of candy has increased. Okay, let's say it's prior to Halloween, it's early October, and we see this happen. Okay, now the price of candy goes up probably a lot during that time, but we'll say that it simply goes up a little bit. And I want you to see, now we set price 2 and bring it across to the curve and bring it down to quantity 2. Now, of course, we know simply the law of demand states from Friday that as the price increases of any product or service, we see a decrease in the quantity demanded. Yes? That's what we just saw right there. So just remember that question, comment.
If on Halloween, price goes up, wouldn't the sale of candy actually go up with Halloween?
So ceteris paribus, you said the sale of candy. So we're going to get to that.
I mean, quantity of candy.
Yeah, you're talking about supply. So let's do, you know what we can do? We can do candy for both of these graphs. Let's do candy first. Let's say this is candy during like July. Sound good? We'll get to your comment in just a second. Okay, this is candy in July. Fine. And we can see here that as price increased just a little bit, eyes of the board, that we saw a significant decrease in the quantity demanded, yes? So very small change in price. For whatever reason, candy went up in July, whatever. And we saw a huge change in quantity demanded. This is our behavior right here. Okay, so go ahead and get that down. So with a small change in price, you might get that in your notes. Small change in price results in a significant change in behavior. This demonstrates the concept of elasticity and relatively elastic demand for something. After you've gotten that down, I'll ask the next question. Give me a nod of your head if you can see we have a small change in price and yet we still behave significantly different. Okay, so demonstrate relatively elastic demand. What sorts of things, goods, products, services, what have you, what do you think are more elastic? Things we want or things we need? Things we want. Okay? The reason being is because wants, guys, wants have, one, they're not necessities, so we don't have to have them, yes? So we can change our behavior. Two, oftentimes wants, they're available substitutes, right? Maybe a certain type of candy has gone up in price. We could have been more specific, and then I just choose to buy what? A different kind of candy, a different brand of candy. Makes sense? So wants tend to be more elastic because they have substitutes available and they're not necessary. Okay? So maybe we get that down in our notes. Let's put this over here. Substitutes available and not what? They're not needed. They're not necessary. And I think we're going to stick with candy, just a different time of year. Effort, thank you for the example. Hope you're doing well at home. I'm having some coffee while we're finishing up there. Are we good? Let's move on to number 2. I'm going to erase. And you guys are going to graph number 2. Yeah, so now we are here. I'm going to draw this graph, relatively inelastic demand. Okay, go ahead and get set up. Do not draw the curve. Like, title this thing relatively inelastic. Let's say we're talking about candy in October. Price and quantity. And now for a relatively inelastic curve, demand curve, it looks like this. Far steeper, yes? And before we continue in plotting all our points and labeling why it's this way, just simply remember that a more steep demand curve would represent more relative inelastic demand. Okay? So the reason for that, what can we say about candy in October? Most people what? Buy it. It's kind of a need that goes along with. It's not an absolute need. Things that are more and more need based would be like medicine that you don't have substitutes for. Does that make sense? Like there's things like I would say I often use this example. In the next month or so, maybe sooner if the weather stays nice. I've talked about allergies before. Some of you are allergy sufferers. I am. I use the Flonase, that nasal spray, and it's like amazing. Saves my life for about 2.5, 3 months in the springtime when there's allergies season happening. And so I would say that my demand for this allergy medication spray is relatively inelastic because there aren't substitutes available. That makes sense? Like I have to have it. It's not like I can go drink some Kool-Aid and call it a day. It doesn't do anything. Or snort the Kool-Aid. That would be weird. But some people do that. Not recommended. Okay, there aren't substitutes available. So that's where we're headed here. So let's demonstrate on our graph, on our curve, why this steeper demand curve is representing relative inelasticity. So let's say we're talking about candy in October, and we'll stick with a price increase. Okay, let's say it went from here, price 1, quantity 1. Go ahead and get that down. Now, what I'm going to draw next, we don't always see it. This is kind of what Eifert was saying. Eyes here. We may see some candy suppliers jacking price way up, correct? Because they know we're going to what? But or you may see, and this is kind of a side note from what we're doing, you may see some candy suppliers raising their prices just a bit to squeeze profit, knowing that a lot more people are buying candy, right? And so they don't want to, they got to kind of balance that out. But let's just say, because it's something that we tend to need during the month of October, need to buy, we see the price of candy going what? Way up. Let's say so for a pretty significant change in price, increase in price, bring it across. We see the same thing, increase in price. Law of demand says we see a decrease in quantity demanded. Yes, a little bit, because it's not perfectly inelastic. But we see a relatively, let me erase that, a relatively insignificant change in our what? What do we call this down here? Our behavior. I hope you can see that at home. Pretty significant change in price, relatively insignificant change in our behavior. Eyes at the board for a second. If we were to make this curve steeper, watch, if we went like this, couldn't we say that this is becoming more and more inelastic, right? That is to say, if it was perfectly inelastic like this, that's to say we would, at any price level, price up here, price down here, we would demand the same quantity. You guys see that? And so not everybody has all the money, but we could say that like life-saving medication, you know, again, people, I don't know if anyone here is diabetic or takes insulin or has that, or we know people that use or need insulin. Listen, the price of insulin could go up, and people that are diabetic still what? They need it. Okay, so let's go ahead and mark these inelastic things with inelastic demand tend to be needs. Okay, needs. That is large change in price, relatively small change in behavior. And again, reasons for that, well, It's necessary for life, not necessarily candy in October, but you get the point. And also there are, what about substitutes? Are substitutes typically available for needs? Is there a substitute for insulin right now? What if when you all walked in this morning, I sprinkled you all with anthrax. I had a little vial of this serum that said, hey, this is the vial of serum that's going to save all your lives. And you're like, what? And I start taking, okay, let's have a bidding war. And you're like, oh, I'll give you $5. I'm like, the heck you will. I'll take all this vial's going to the what? Highest bidder. In fact, I'm going to hold, if there's enough for all of you, I'm going to make sure you all pool your money together and I'm going to get every dollar in every pocket in here. Does that make sense? So because there are not substitutes available. Okay, substitutes are not available for things that are needs. Now, maybe our example is not perfect at home. You understand the point. I hope candy during October, we're demonstrating that people buy it because it's essentially a need for the month of October with Halloween coming. But something like medication, healthcare things. Now, can everybody afford things that are needs all the time? Housing, healthcare, no. So we're going to get into it this semester where the government may get involved in these markets, right? By the government saying like Obamacare is an example of a government price ceiling. We'll get to that later, but that is where the government steps in and says, hey, the price for healthcare is too expensive and we need to do what to it? Decrease it to make it more affordable for people, the Affordable Health Care Act. Does that make sense? So things that are necessities, the government may step in. I mean, think about it. There's, is it EBT cards, right? There's like money through the welfare system, like for things like necessities like food, right? And housing. I mean, these are things that government helps provide for people who otherwise can't afford them, okay? Nod your head if this makes sense. All right, cool. Next thing I want to do is take you into the concept of calculating elasticity. So we're going to go today, and then this will round it out. So please flip it over to the back, unless you have a lot of room on the front. It's kind of up to you. But we want to determine if we have values, numbers, and we don't have a graph, how do we know if something is elastic or inelastic? Okay? First off, in your notes somewhere, if there's a value, this is just a little like a key for you. Value greater than 1 equals relatively elastic. And if we end up with a value in our calculations of less than 1, we're going to say that that product, good, service, what have you, is relatively more inelastic. Okay?
We still have a left and right side.
No, I mean, if you want, I would probably do this on the back side. If you haven't done that, that's fine. You can erase your line. This is for both. You could put this value over here on the left side of your deal. You could put this value on the right side. Okay, but we're kind of starting over in same concept, elasticity, but a new portion of it. Calculations. You could call this section calculations. Okay. All right. In order to do calculations, we're going to need to use a couple different equations. First off, ultimately, what we're doing is this. We're trying to find the elasticity value. That's equal sign. Okay. Elasticity equals percent change quantity demanded divided by percent change in, not quantity, sorry, in price. So if I took this graph right here, as over here, If I took this graph, it's relatively elastic demand. I want to find, we had our 2 points here, right? I'd want to find percent change in quantity demanded. Sorry. See the bottom, percent change. What's the percent change in quantity demanded versus the percent change in price? The difference here versus the difference here, divide it, and that'll help us figure out our answer. Okay? That's what we're trying to calculate. So your number one equation you have to go back to, what you're ultimately calculating in the end is what? What are we calculating? Elasticity, okay? And if the value in the end is greater than 1, it's going to be relatively what? And if it's the value in the end we calculate it's less than 1, it's going to be relatively inelastic. Okay. So to calculate each of these, we have to do what's up. This is probably, and you're like, I thought you said there's no math. I told you there's going to be a couple times where we do some calculations, this being one of them. This is it, okay? There's not a bunch of it. But in order to find this up here and to find this percent change down here, we have to use a percent change problem or equation. And you may recall this from your math classes, okay? Percent change looks like this. Original number minus the new number divided by the original number times 100. I'll let you get that down and I'll explain. All right. Eyes at the board when you're ready. We may have to use this 2 different times because we need to find a percent change in quantity demanded, and we need to know a percent change in what? Price. So we may, depending on what they give us, we may have to use this twice. Get a value here, plop it up here. Get a value here, again, plop it down here. So I'm going to keep this. I'm going to get a clean whiteboard, and I'm going to read you a scenario. In fact, why don't I just bring it up? Easier to see it this way. Oh, thank you. For you people at home, I haven't left you, don't worry. Probably wish I had. All right. Let's go ahead and do number 1 together. An increase in the price of orange juice from $2.39 a gallon to $2.45 a gallon is accompanied by a 2.5% decrease in sales. Okay? So we know that we already know the percent change in quantity demanded, but we don't know the percent change in price. Okay? So I'm going to go ahead and just do this right here with you. Okay? So we need to calculate elasticity. And to do that, we need to find percent change in quantity demanded over percent change in price. Everybody with me? Go ahead and do this. Your notes. You're doing these with me. We have 3 or 4 examples to do. I'm actually going to do that. Okay. What's that? D. That's a D. Sorry. Quantity. So again, all that is right there is the same as this right here, guys. Look. No, never mind. It's the same thing you wrote above, right? So go ahead and get that down. Based on this example, we don't know which one of these. We don't know the percent change in price. So we do know that the percent change in quantity demanded is 2.5. That's this right here. But we don't know the percent change in price. So we have to, we're going to leave that blank for a second. So how do we figure out this one? We go right back to, once you get that down, I'm going to go right back to this. This equation right here. Let's go ahead and plug in our values. Get out a calculator if you want. Do we have a calculator? Like, no, it's on my phone. You made me put it away. Calm down. Okay. If we plug it in here, what on that scenario, what was our original price number?
239.
Went from 239. So go ahead and plug in 239. Okay, you can just write this out on your paper. 239 minus what was the new price? Up to what? 245. Okay, you should all be doing this. Just on your notes. What's the problem? So we have 239 minus 245. We're calculating a percent change in price here. Divided by the original price of 239, all times 100. Okay? If you do this on your calculator, 239 minus 245 divided by 239 times 100. Anybody have a calculator? Anybody do it? Was it? 2.5. Okay, equals 2.5. So to go back to your original equation, plug in right here, 2.5 equals what? 1. Now, like, that's weird, actually. I thought if the value was greater than 1, it was elastic, and if it was less than 1, it was inelastic. If it is perfectly 1, we would say it is called this, unitary elastic. So, okay, if you get a value that is 1, we call it unitary elastic. What's that? Because it's unit to unit, it's 1 to 1. It's like saying this. I'll write it over here. It's like saying if this is your demand curve, instead of a flat one like this or a steep one like this, it's like 1 to 1. The slope is 1 to 1. It's unitary elastic. There's an equal change in price as an equal change in your behavior. Make sense? Okay, so that's what that's saying. Let's go ahead and do the next one together. Does it help? Does it help to do it here, or does it help to just do it on the whiteboard? What would you prefer?
Whiteboard.
Whiteboard? Okay. So then here's what I need you to do. I need you to write these values down then before I pull it, because I'm going to talk about it and I don't want you to have to go back and forth. What's that? Yeah, number 2. An increase in the price of gasoline from 99 cents to $1.39. Increase in the price of gasoline from this price to this price. So we don't know the percent change in price again, do we? Okay. Is accompanied by a decrease in the sales, 0.5%. All right, I'm going to pull this. Okay, I'm going to start writing it down myself on the whiteboard for you. Remember, we want to calculate elasticity equals percent change in quantity demanded divided by percent change in price. In that situation, we don't know this one yet, do we? Do we know this one? What was the answer? What was the number for that? It was 0.5. And we're still waiting to solve for this. All right. Okay, so this is a question mark here. So how do we solve for that? We use percent change equation. This time it's price. We take what number, the original or the new number first?
Original.
The original number price was what? 99 cents minus what?
$1.39.
$1.39 divided by 99 cents times 100. Somebody go ahead and calculate that out on your, what is it?
40.4.
This minus this divided by this times 100 is 40. Oh, 40? Are we good? We plug that in up there. We end up with elasticity equals 0.5 divided by 40. Is that greater than or less than 1? Way less than 1, isn't it? Is less than 1, which equals what kind of elasticity? Relatively what? You could leave it like this. You could divide it out. If you were to divide it out, I think it's like 0.0125 is less than 1. Yeah? I don't care if you leave it in a fraction or in a decimal. So all we're trying to figure out is it, look here, is it this or is it this, right? And or is it unitary? Is it exactly 45-degree angle, 1 to 1? Let's do another one. Go ahead and reboot. I know you're like, some of you are good with it, some of you are not. We're going to do another one so that you get good with it. I'm going to go ahead and zoom in again so you can see it. We're on number 3 now. Go ahead and get your values down. Number 3 says, a decrease in the price of tacos from $2.35 to $1.99. We have to figure out percent change in price, don't we? Causes an increase in sales from 1,225 tacos to 1,550 tacos. We also have to figure out a percent change in quantity, don't we? So we have to do the percent change equation how many times? Twice. I said we might have to do it twice, okay? So can you guys please write those values down just somewhere on your paper? Go price 235 to 199 and quantity 1225 to 1550. Can we do that? Yes? Okay, because I'm going to go to the whiteboard and I don't want to pull it from you yet. Okay. About 5 minutes, perfect. Okay. So we need to do percent change. Again, what's that? This is number 3. Number 3. We have percent change in quantity demanded and percent change in price. So first off, as far as quantity goes, what was our original quantity number? 1225, you guys agree? Minus what? 1550 divided by 1225 times 100. Somebody calculate that out for us. Do it again.
Oh, I was confused.
Just, yeah.
-26.5.
Okay.
I definitely did.
And for all intents and purposes with elasticity, we just drop the negative, absolute value, okay, 26. Okay, so we're going to call this one 26. And now we need to solve this percent change equation again. And our original price was what? What was it? 235. 235 down to what? 199. 199 divided by original price again, 235 times 100. And now we want to calculate for change in price. Somebody solve for that, please.
15.3.
I heard a 15. Anybody else? Cora, you seem to have the other calculator. What'd you get?
114.
Do 235.
That's what I did.
Do this. Hit equals each side. 235 minus 199 equals. Divided by 235 equals. times 100 equals.
15.3. Oh, I didn't equal it. I just did it all.
I know.
I didn't.
That's why we did that.
I'm stupid.
No, you're learning. We just told my 3-year-old this the other day, like, actually, I'm not a 3-year-old. My 3-year-old was freaking out about something, and we're like, hey, dude, because he was trying to build something. He's like, I can't do it. And it keeps making a mistake. He learned this word mistake. It keeps making a mistake. Like, that's how you learn, man. You make a mistake and you change it, right? That's learning. So don't get too pissy about it. All right, 26 divided by 15. Is that greater than or less than 1? It's greater than 1. Okay, so it's relatively what? Elastic. You good? I'm not going to do number 4 with you. Okay, you understand generally what we're doing. Okay, nice job today. I'm going to go ahead and stop our recording. People at home, have a nice life. Thank you for playing.